don't have controller. When we talk about the controller, we should think about the PI controller, PR controller, I don't know, predictive controller, adaptive controller, AI-based controller, this type of, but we don't have a still controller. So we go forward to see what is happening. Now this is our equation, and then we are going to actually connect the converter to the grid. We said that we have we are going to provide the services to the grid, and then so assuming that this is my grid, this is my grid, and then this is my converter. And we have a switch here. So if the frequency of the grid is 50 hertz, and in this time my converter is going to connect, so it will be like this. Is it true? Yes? Do you agree this is like this? It should be like this because we are going to create voltage and current in 50 hertz. So the frequency when we connect should jump to 50 hertz. Yeah. Is it possible? Is it that much easy? Yeah? No? Why? Mm-hmm. Why is not possible?
Stable at 50 hertz,
Mm-hmm.
we need to operate our armature at certain speed, and
Mm-hmm.
for that we need a certain input, for
Mm-hmm.
example coal or steam. So it takes a lot of time to stabilize it at.
You say that lots of time. How? I mean, it's how long? It's
For
1
example,
hour.
if a freshly new generator we are connected to the grid, it takes at least 1 to 2 hours.
2 hours to be stabilized.
Without the automated control. With automated control, it can be done in 10 minutes.
No, without automated control, we cannot actually stabilize it. It will be like a load, something make the disturbance for the grid. But what you are saying is almost correct. But we cannot refer to this one as a correct one. But there are some reason that we need to consider. What's your name? Action. Akshaya. Akshaya. Thank you, Akshaya. Yeah. So, what we are actually, the desired value is that when we connect, for example, t equal to 0.5, we close this one at t equal to 0.5, then the converter provides immediately power to the grid with 50 hertz, and then in fact the frequency of converter injected power goes from 0, because before connection it's an open loop and it doesn't provide anything. Then the frequency is 0. Okay. Then when it goes to connection point, so it goes to 50 hertz. But the problem is that we have the physical devices that goes like this. Okay? This happening. So we have actually oscillation. It goes like this one. So we call it transient time here, and then it reached to a steady state. Okay? So as long as your controller is tuned well, this transient time will be less. And this overshoot also be less. So you remember in control, linear control, we had actually this overshoot, and then for the PID controller, and also this settling time. So this is the place that you must use that theoretical part in practical. Okay? So as much as this time is less, in fact, our system is more stable. You remember when I touched the Abe, it was very strong. It means that his inertia was high and settling time was very fast. It was like this. It connected and like this. But my inertia was less. When he touched me, I was like this one, swinging and then this. Okay? So, conclusion. When this type of integration happening, there are two important things that you should consider. First, your controller should be tuned in a right way that minimize the transient time. And second is that one factor which can damp this transient fast is inertia of the grid. So what is the definition of the inertia? Is a type of the energy or power which resists against changes. So if something make any changes in the frequency of the grid, inertia damp it faster. Okay? So now we are talking about the controller for the converter. So we have no idea about the grid. Grid can be strong, weak. I don't know what is happening. But my responsibility as an engineer is to design my controller in a way to have the minimum fluctuation or minimum transient. So does anybody knows that if we don't consider this one, what is happening in the grid? So assuming that why we should actually minimize the transient? We have a ripple, yeah. So when the frequency is 50, it means that we have a stable system. But when the frequency somehow actually swing, so it means that the system is not stable. So this type of, one of the weakness of converter-based generator is that they are not going to provide a stable actually synchronization, and they provide disturbance for the grid. So if we have actually huge amount of the power conversion system based on the power electronic devices, then assuming that we turn it on, each of them apply disturbances to the grid, then grid will be polluted by this. So this is why we should consider the solution for that one. So what is the solution? The solution, now we get some idea that, okay, yeah, we learned about the PID controller, and then PID controller can reduce or minimize the value of the overshoot and settling time. So we need it. And now get back again, we see that the switching is the important part of the converter. So if we transfer this actually parameter to the other side, and we get the switching based on this, okay? Now any changes happening in the network can be seen in the control loop of the converter, okay? So just simply we call it lambda is equal to L di to dt plus Ri. But it doesn't matter. If you don't like, you don't put it. Doesn't matter, okay? So now we have a stupid term, we call it lambda. It's coming from where? From a sky. We don't know. But one thing is that we consider, why we consider L di to dt plus Ri equal to lambda. So let's see. But before I start that one, I'm going to just briefly show you what is the mission of PI controller in the control of the converter, and then we get back to lambda. So assuming that I'm going to inject 10 ampere, so I reference that I need is equal to 10 ampere, okay? So then I control my converter, and the injected converter current, I converter, is something, okay? It can be 1, 11, 9, I don't know, whatever you want, okay? So then I said that if I subtract 10 minus IC, anything happen will be error, okay? Do you agree? So assuming that I have a converter, DC, AC, and I ask about 10 ampere, so converter current, and I reference is 10 ampere. I reference means 10 ampere means that I need 10 ampere. I need converter inject 10 ampere to the grid, okay? But I measure the current which is really 10 ampere or something else, 9 ampere or 11 ampere. So this controller is working well when the reference current and injected current are the same. So it means that I ask converter, please inject 10 ampere, and this converter inject 10 ampere. I ask 9, it inject 9. I ask 8, injected current is 8. So it means that converter is working well, okay? So if we have something here, 10 minus I converter, if it is not equal to 0, in fact, we have an error. So now get back again to what we discussed about the synchronization of the converter in 0.5 seconds. So this is the frequency 50. Then we have actually this fluctuation, okay? So it means that the current we are injecting to the grid from converter follow this frequency, but the grid frequency is this one, okay? So the current injected from the converter is not equal to 0 because we have different. So it is I sine omega t. So omega t is 2 pi f is 100 p for this one. But for this one is I sine omega t, but omega t is changing. So it's like it's not 2 pi f because the frequency is changing. Okay? So by this assumption, delta I, which is I reference minus I converter, is not equal to 0. 100% clear or 99%, 98%? Because if you don't understand this one, you will not. So did you get my point or not? Yes or not? Okay. Yes? Okay. Do we have 99%? All 100%? Okay. Professor, you are witness. If later they don't know anything, it is not my fault. Okay. Udaya, do you have any comment? Okay, thank you. Thank you for confirmation. So now we said that, okay, it is not actually equal to 0. But I said that, okay, in the control system, we use the PI controller, and the PI controller provides this opportunity for us that after sometimes, okay, we minimize this one and go by this way. So, and reduce this part, okay? So a PI controller is needed to follow. Otherwise, if we don't consider the PI controller, it cannot actually reduce the swing value. So it's always swinging like this one. So PI controller just return back this current to follow the reference current and minimize the error, and after some cycle it goes to the zero value. Okay? So this transient time, as much as we reduce this transient time, our system is working better. Okay. So now we get back about this stupid question that lambda is, why lambda is L di to dt plus Ri. Okay? So now get back again to this one. I reference minus I measured, which is delta I times 2 K P plus K I over 2S. This is PI controller, yeah? PI controller was the integral part and also the constant part. So if we get back to this one, delta I K P plus K I over S delta I. Do you agree by this equation? So delta I K P delta I plus K I S delta I. So what is the meaning of this one? So if we get the integral of delta I, because 1 over S is equal to integral, and we have delta I di is equal to I. So it seems that this can be removed by I. Okay? And this is copy di to dt. So conclusion will be copy di to dt plus I. Okay? Ki is the value for the constant value, okay? And P is also constant value in PI controller. If you open the MATLAB in PI controller, just click on it. You should actually tune the Ki and P. So by this, if we consider Ki equal to R, P equal to L, you see that is it possible to consider lambda equal to L di to dt plus Ri? Yeah? So I said that if we have I reference minus I converter is delta I times 2 P plus Ki over 2S equal to lambda. Is it correct? Yes or no? Delta I di to dt times 2 P Ki Ks. So you tune the value of P and Ki. Okay? So it can be matched with the value of the impedance we have. So at the end, we can easily call delta I times 2 P plus Ki over S is equal to lambda. Do you agree? Yes, tell me.
Actually, if you take integral part and
Mhm.
proportional to pi,
Mhm.
in that case, the surge current will be very large.
Yes.
And that may produces huge harmonics.
Yes. Okay.
That's
But
possible.
do you have any solution to provide
Time,
the
I'm
exact?
agreed, time will be less in pi
Mm.
compared to pi
Yeah.
settling time.
Mm.
But what about that harmonics?
Harmonics can be actually filterized. Yeah. Because we get the feedback from the injected current after filter. Okay. So then the injected current, you see that I need 10 ampere. But what provided by converter is something 10 ampere plus harmonic. But the injected current from the converter pass from the filter. Then we have actually the 10 ampere. But what the converter provide is combination of the 10 ampere and harmonic. But it can be actually removed. This is why we use actually this. But yes,
Small doubt.
yeah.
Actually, when we are going to consider the line impedance,
Mm-hmm.
we are going to write R and L component.
Mm-hmm.
But we have to consider the capacitance is also there.
Yes.
In that case, is it possible to use only PI?
Only PI?
Lambda is considered according to that equation.
Look, let me answer your question by different way. I mean, do you have any specific equation to guarantee that the value of the Ki and Kp is 100% matched with the control loop? How do you calculate the Kp and Ki?
By QI.
But in real system, I mean, later we see that we have an equation for that one. But what we calculate by equation is completely different from the simulation and completely different from the experimental. Okay? We normally tune it. We cannot actually calculate it. But we have actually get some idea about, so for example, if Ki is this, P should be something completely different, and you consider the actual frequency, this type of things, and based on that, you can guess. But you cannot actually say that, yeah, this is my simulation, and I'm 100% sure if we consider Ki by this value and Kp by this value, it works very well. No, it is absolutely impossible. So for this reason, and the reason is that, we have cable. It has the resistance. It has actually we have also transformer. We have actually grid. So these type of the element they have a physical they are physical components, and you cannot measure that one. So when you cannot see the impacts, but you don't know what is. So for this, used by transformer and reach right value. So this is the problem of the PI. I think that in industry, PI controller is most because the technology is nowadays. But I can promise very should jump to the another. Yeah. There are actually all the understand the root controller, and later you see that them are following the thing with the different. But again, this, ladies and gentlemen. So clear now. Consider ln because we define the equal to L dt plus R. But now we say after delta R and put a PI and because why? More explanation. Yes or no? Say something. Yes. It will be part of your exam. I don't like you fail for. We talk about this later. Later you could not solve it. It's a problem. Okay. So I'm assuming that you get it on. Now we have the PI. So we said that basically understood that mission of the PI controller is to use the actually time and also to match the frequency of the injected power with the frequency of the reference. So then by this, we can also provide the right value from the converter based on the reference current we define for it. So, shall we start, continue or stop it? Stop it? Okay. So let's have some minute break and then we get back again. I can continue if you want, but the big boss is here and then